Hello everyone, welcome to your session 5. So in this session we will be discussing our questions on liquids in rigid motion. Now, as I mentioned before, so in your rigid body motion, in your motion of the fluid in the vessel, after initial change, your fluid behave as your rigid particle. Okay, so no relative, as I mentioned 2 points here, no relative motion. Oh, but I don't need to mention them here. Okay, I think you all should know that it is called liquid in rigid motion because after initial deformation, your fluid in the container act as a rigid body. Okay, now there are two type of rigid body motion. First is translation, second is your rotation. Okay, so if I talk about translation motion, translation motion. So here your equation for rigid body motion is given by gradient of pressure plus rho g k cap is equal to minus rho a vector. Okay, so this is your standard equation for translation motion in a rigid body. Okay, now if I talk about your respective terms, respective your three directions or orthogonal directions, so your del p by del x is equal to minus rho x, your del p by del y is equal to minus rho ay, and your del p by del z is given by minus rho times of az plus acceleration due to gravity g. Okay, now here this term collectively is called as g effective, so minus rho g effective. Okay, effective your effective acceleration due to gravity. Okay, now we have seen your various cases. Your for fluid at rest, we have seen that only this equation is valid, that is ax, ay and az are 0. For fluid at in your free fall, your az is equal to minus g. So in case of free fall, as I mentioned, in free fall we know that our your gradient of pressure is equal to 0. Okay, it means that all three respective terms are 0. So what does this imply? This implies that pressure at all points are same and are equal to your local atmospheric pressure. Okay, now if I talk about your slope in case of 2D, or let me mention it here, for acceleration in straight path or straight line. Okay, so what we can say here, we can say that we write it as your p is equal to function of x comma z. So from here we write dp is equal to del p by del x times of dx plus del p by del z times of dz. Okay, and this can be written as del p by del x is your minus rho ax times of dx minus, let me make some space here, minus rho times of az plus g times of dz. Okay, so this is your equation for pressure. Now from here, if we calculate your slope, so we write tan theta, that is your slope, is equal to minus ax upon az plus g. Okay, so this is your slope, and this is also like slope of your isobar. Okay, now if your acceleration in x direction is equal to 0, so your surface will always remain horizontal, and if your if your acceleration is not equal to acceleration in x direction is not equal to 0, in that case it will always form a slant surface. Okay, and if I want to let's say find pressure at any point inside the liquid, so I can say, I can use this equation, del p by del h is equal to rho g effective. Okay, and using this equation we can calculate the pressure, gauge pressure at any point. Gauge pressure at any point is rho g effective times of h, and after that we can also calculate your force on the surface. Force on the surface, and that force is equal to rho g a h bar. Okay, force on any surface is equal to rho g a h bar. This is your force on surface. Force on surface. Okay, and second type of motion, rigid motion, is your rotational motion. So if I talk about rotational motion, so in case of rotational motion, what are the important points? That your del p by del r is equal to rho r omega square, your del p by del theta is equal to 0, and your del p by del z is equal to minus rho g. Okay, and if I write your equation, that is for 2D flow, if I write your p is a function of your r comma z, so from here I can write my dp is equal to del p by del r times of dr plus del p by del z times of dz, and this can be written as your rho r omega square dr minus rho g dz. Okay, so this is your standard equation for your rotational motion. This equation is your standard for your rotational motion. Okay, now here I mentioned this equation. This is also obtained. Okay, and similarly here it is, this equation is your standard equation. Now for isobars, if I talk about your slope, so your dz by dr comes out to be r omega square by g, this is your slope. Okay, is equal to tan theta at a distance r. Okay, and if I talk about your height of, like, let me draw a diagram here first. So let's say that this is your container, and this container is rotated about this axis, and this is a free surface formation. Okay, and if I say that h is the height of this, okay, so we know that the surface is paraboloid. So volume, h is equal to your r square omega square by 2g. This is your height of paraboloid. Okay, and your volume of paraboloid is equal to pi r square h, that is volume of cylinder, divided by 2. Okay, so these are some important points here which we will generally use it here. Okay, and we can also like calculate your pressure at any point inside your rotating cylinder. Okay, and that pressure we will calculate using this equation only. Okay, so now let's start your first question. So this is your question here. So a water tank is being towed by a truck on a level road, and the angle of free surface makes with the horizontal measure to be 8 degree. Determine the acceleration of the truck. Okay, so let's draw the figure here first. Okay, so this is your truck, and let's say this is your water tank. There are wheels. Okay, and it is kept on a solid ground, and this initially this was the water level. Okay, this should have been the water level. This should have been the initial water level. Now now what is happening that this container is, let's say, moving at an acceleration a. Okay, and of course g is acting in a downward direction. G is acting in downward direction. Okay, and due to the acceleration, your free surface becomes something like this. Free surface becomes like this. Okay, so this is your free surface now. Okay, and this makes an angle theta. Okay, now from our previous study, we know that the slope tan theta is equal to ax minus ax plus divided by az plus g. Okay, or basically I can write here g effective. Okay, now I know that my ax is here. Okay, but before that, so it is given that angle of the free surface makes with the horizontal 8 degree, that is theta is equal to 8 degrees. So tan of 8 degrees is equal to minus ax is your a. Okay, and g effective will be your acceleration due to gravity only, it is 9.81. Now if I solve this, so this will become your tan of 8, sorry, 8 tan of 8. Okay, and this is in degrees. Okay, times of 9.81. Okay, one more thing here, that this tan theta indicate basically slope. Okay, and this negative sign is showing the direction, what is the value of slope exactly. Okay, so if I talk about theta, so that is slope, so slope should be, this angle should be the slope. This is your, let me write it as theta. Okay, theta, so this would become your tan of 180 minus 8. This is, let's say, alpha, so 180 minus 8. Okay, so 180 minus 8, tan of 180, 172. Okay, multiplied by 9.81. This gives our a is equal to 1.37 or 38 meter per second square. Okay, and if I want to, let's say, use alpha here. Okay, sorry, so here I think I have made some mistake in your lecture here. So while I was mentioning tan theta, so it should be your plus. Okay, because theta I have taken as your 90 minus alpha. Okay, so wait a minute, let me correct this. So here I mentioned that, let me look it out. So here, so your dz by dx is equal to slope. Okay, but tan theta I mentioned, I have mentioned theta is this. Okay, and this is so tan theta will be your ax upon az plus g. Okay, and hence your tan theta here will be ax by g. Okay, now back to your question. So here I can write my tan alpha is equal to your ax upon g effective. Okay, now I can directly put alpha is equal to 8 degree here, or I can since 8 degree is very small angle, so I can write it as 8 into alpha is, tan alpha will be equal to alpha, so I can write it as this in radian is equal to ax, that is a, and g effective is 9.81. If we solve this from here, I will obtain my a is equal to 1.37 meter per second square. Okay, so this is your approximate result. Okay, or if I directly put like here tan 8 degrees, then your answer will remain the same. Okay, now let's move to next question. So here 75 centimeter high, 40 centimeter diameter cylindrical water tank is being transported on a level road. The highest acceleration anticipated is 5 meter per second square. Determine the allowable initial water height in the tank if no water is to be spilled out during the acceleration. So here it is, like it is mentioned that this height here is your 75 centimeter, or let's say it capital H. Okay, and the diameter of the container D is given. Okay, so your H is equal to, capital H is equal to 75 centimeter, and your diameter is equal to 40 centimeter. Okay, now it is mentioned that it's transported on a level road, the highest acceleration possible. So A max is equal to 5 meter per second square. Okay, and determine the allowable initial water height in the tank if no water is to be spilled out during acceleration. So we have to calculate what should be this H max. Okay, so I can write what I can write. I can say that my tan of theta and theta is this angle. Okay, tan theta is equal to ax upon g effective is equal to your ax is your 5, g effective is equal to 9.81. So if we solve this, so 5 divided by 9.81, so this value is here, so tan inverse of this. So from here I obtained theta is equal to 27 degrees. Okay, or this value is equal to 0.51. Okay, now what I can say from here, I can say that my theta value, I know the theta value. Okay, so if I want to calculate this height, okay, so like if I want to calculate it for, let's say, maximum like maximum acceleration, that this acceleration to be maximum such that no water spillage occurs. So just before the spillage, this should be our condition. Our condition should be like this, like it reaches here, this point is here. Okay, and okay, it should be something like this. Okay, I hope you get this point. Okay, so this should be our final condition. Now we know that this rise in height, here, that is, let's say, the rise is your x, rise at this end is x, and fall at this end will be your again x. These both rise and fall are both equal. Okay, so I can find my value of x as x is equal to or my tan theta is equal to your x upon this distance. This distance will be your d by 2. Okay, it is your d by 2. Okay, is equal to 2x by d. If I substitute the values here, so from here I will obtain my x is equal to, so let's write the values here. So tan of this angle, this value, multiplied by your diameter d, that is 40 centimeter, 40 divided by 2. Okay, so x is equal to your 10.2 centimeter. Okay, we have obtained the value of x. Now if I want to calculate your h max, so I can write my h max value as your capital H, your from here, if you see this is capital H minus x. Okay, so capital H is just 40, so 75 minus 10.2. Okay, so if I solve this, so this will become your h max is equal to 64.8 centimeter. This is your answer. This is your answer. Okay, so this is the allowable initial water height in the tank, so that no water is spilled out. Okay, during acceleration of 5 meter per second square. Okay, now let's move to next question. So here, consider two water tanks filled with water. First tank is 8 meter high and is stationary, while the second tank is 2 meter high and is moving upward with an acceleration of this. Yeah, higher pressure at the bottom. Okay, so it's something like this. Let me make some corrections here. Okay, now here 8 meter high and second what is 2 meter high. So let's say that this is your first tank, tank A, and similarly we have also have a tank, and that is tank B. Copy and paste. So this is your another tank. So this is your tank B, and it is given that water level in tank A, first tank is 8 meter high. So this is your water level. Let's say this is your water level, and this height is your 8 meters. Okay, and this is the tank B, while the second tank is 2 meter high. So water level in second tank is your 2 meter high. Okay, this height is your 2 meter. Okay, now he is moving first tank 8 meter station. So this tank is like only your acceleration due to gravity is acting here in second tank, while the second tank is moving upward with an acceleration of, so we have az is equal to, or I can say that AC moving upward with your acceleration of 5 meter per second square, and moving downward acceleration of g is acceleration due to gravity is always acting. Okay, which tank will have higher pressure at the bottom? Okay, so let's talk about your pressure at bottom first. Of the A tank A. So pressure at A bottom. Okay, so pressure will be equal to, as I mentioned, that the pressure is your rho g effective times of H. Okay, since first tank is your stationary, so your H so g effective will be G, and your H is 8 meter. So if I substitute the value, so 9810 into 8, so this is 78.48 kilopascal. Okay, now P in B at bottom. So this again will be your same rho g effective times of H. Okay, now density is your 1000. Now if I, effective will be your G plus 5. Okay, because if we sit on this container, so your net downward acceleration will be your G plus 5. Okay, the acceleration provided to container will be your relative to container will be in downward direction. Okay, so this times of H, that is 2. So if I substitute the values here, so this will become 9.81 plus 5 into 2, that is your equal to 29.62 kilopascal. Okay, so from here we can say that pressure at A is greater, pressure in bottom at A is greater than that of pressure at B. Okay, now what there is a point you should always remember in these type of questions. Okay, what should be your G effective? Okay, so G effective is basically relative acceleration due to gravity. Okay, so if your acceleration Z, that is your AZ, this is in upward direction, in that case your G effective is equal to G plus AZ, and if your AZ is in downward direction, so your G effective will become G minus AZ. Okay, so let's me move it to your theory portion here. Okay, Let me paste it here. Okay. Now, this is your next question. A fish tank that contains 60 centimeter high water is moved in a cabin of an elevator. Determine the pressure at the bottom of the tank when the elevator is stationary, moving with an upward acceleration of 3 meter per second square, and moving with an downward acceleration of 3 meter per second square. Okay. So in all these three cases, we have to calculate your uh, pressure. So let me mention these three conditions here. So one is like, okay. So sorry. So this is your case A, this is your case B, and this is your case C. Okay. Now this is your stationary. This container is stationary. Okay. And only your acceleration due to gravity G is acting here. Now G will be at all three places. Okay. Or okay. Okay. G is acting on all three containers. Now, if I talk about my acceleration, so Az here is your Az is equal to 0. Here your Az is equal to, so it is moving upward. So moving upward is your positive, that is your 3 meter per second square. Okay. And here Az is equal to, in downward direction is your downward acceleration of 3 meter per second. So this is minus 3 meter per second square. Okay. Now since I have to calculate the pressure at bottom of each tank, so I will calculate pressure at bottom of each tank. So pressure, we know that pressure is equal to rho G effective times of H, or let me write it like this. So pressure is equal to rho G effective times of H. Okay. Okay. One more thing. Your height is 60 centimeter high. So this liquid height is your 60 centimeter. Okay. On all three. Okay. Now this is your, like, since Az is equal to 0, so this will be your rho times of G times of H. Okay. And if I solve this, so PA is equal to rho GH. So G is your 9.81 into H is your 60 centimeter, that is 0.6 meter. So this is your 5886 pascals. Okay. Now if I talk about your pressure at B, so pressure at B is equal to rho times of, so G effective, here your G effective will be G plus 3 times of H. Okay. And your like G plus 3 will be your 9th plus 3 12, so 12.81 into your H is, that is your 0.6. So this becomes your PB is equal to 7686 Pascal. This is your PB. Okay. And in case of C, so PC is equal to rho times of, now here G will be, G effective will be G minus 3 times of H. Okay. So PC is equal to, now G minus 3 is your 6.81 into H is your 0.6. So this is your 4086 Pascal. So this is your PC. Okay. Okay. So these are the pressure in these three conditions. Now let's move to your next question. A water tank being towed on an uphill road that makes 14 degree with the horizontal, with a constant acceleration of this in the direction of motion. Okay. So let me draw it first. Uphill, we are towing it uphill, makes an angle at 14 degree. So it's something like this. Okay, sorry, let me draw it on this side. Okay, so this is your, this angle is your alpha is 14 degree. Okay, now your container is here. So it's something like this. One minute. So it's something like this. Okay, so it's something like this. And okay, your container and is constant acceleration. Uphill is your, that like this value of this a is equal to 3.5 meter per second square. Okay, and determine the angle of free surface of the water makes with the horizontal. Okay, so initially what would be the case? Initially this should be your free surface. Let's say this is your free surface initially. Okay, but due to the motion, it would become something like this. It would become something like this, or something like this. Okay, okay, it becomes something like this. Now we have to say determine the angle of angle the free surface water makes with the horizontal. So let's say this is your theta. Okay, we have to determine this angle theta. What would be the answer if the direction of the motion to be downward in the same road with same acceleration? Okay, so this is the first case. Now in such type of questions, what we do, like if I talk about my acceleration due to gravity, so your g will always act in your vertical downward direction. Okay, so this is the direction of g. Okay, and this acceleration, what we do, we make two components for this. We like break it into two components. Okay, now these two components are, these two components if I talk about, so one will be in this direction. Okay, let's say that if this is a, if this here is your a, okay, so your component, two components will be, one will be this component, that is your ax. Okay, this is your x z. Okay, and this component is your, like up to this point only. Okay, this is your az. Okay, now what else I can say here, that this angle will be your alpha. So from here I can say my ax is equal to a cos alpha. Okay, and your az is equal to, az will be your a sin alpha. Okay, so if I calculate these values here, we know that alpha is equal to 14 degree, that is your 3.5 times of 14 of cos. Okay, this is your 3.4 meter per second square. Okay, and your AZ will be 3.5 times of 14 sine of 14. Okay, so this is your 0.84 or 85 meter per second square. Okay, now using this AX and AZ, your system again becomes your like your previous systems. So here I can say that my tan theta will be tan theta is equal to AX upon G plus AZ. Okay, if I substitute the values here, so AX is your 3.4 divided by your G value is your 9.81 plus AZ, that is your 0.85. Okay, so let's solve this. So this becomes your 9.81 plus 0.85 inverse of this multiplied by 3.4. So tan theta is this, and if I take tan inverse of this angle, so your theta is equal to 17.7 degrees. So this is your angle the free surface of the water makes with the horizontal. Now second case, it is asked that what would be your answer if the direction of the motion to become downward on the same road. Okay, so let's say that in the same case, if we have your acceleration like this is your a dash. Let's say this is your a dash. Okay, so in that case you will obtain this as your ax, and this as your az. Okay, and due to acceleration being in this direction, and this angle will be your alpha. Okay, this angle will be your alpha, and due to acceleration being in this direction, your free surface will be something like this. Okay, free surface will become something like this, and from here we can write your ax is equal to your again a cos alpha. The values will be same. Okay, but in the calculation, if I it is asked what to do the direction of the motion to be downward. Okay, so if I want to evaluate theta, so let's say that this is our theta dash. So if I write tan theta dash, so that will be equal to again ax. Ax is your value is 3.4 again, like same value, upon your G effective. Okay, now your ax is equal to your 3.4. If I talk about G effective here, so G effective will be G minus az, because az is in your downward direction. Okay, so 9.81 minus 0.85, and inverse of this multiplied by 3.4. Taking tan inverse, we have obtained your theta is equal to theta dash is equal to your 20.78 degrees. Okay, so if we change the direction of the motion to downward on the same road, then what would happen? Then your the angle made on the free surface with the free surface of the water, angle made by the free surface of the water with the horizontal will increase. Okay, now we will move to our next question. So in this question, it is mentioned that a 3 meter diameter and 7 meter long cylindrical tank is completely filled with water. The tank is pulled by a truck on the level road with 7 meter long axis being horizontal. Determine the pressure difference between the front and back end of the tank along a horizontal line when the truck accelerates at 3 meter per second square and accelerates 4 meter per second square. So it's like this. We have a cylindrical container. Let's say this is a container. Okay, and this is a cylindrical type. Okay, now in this container have your diameter of, okay, or let me like draw ellipse here. Okay, there it is a ellipse. Okay, okay, something like this. Okay, now it's like this. Okay, so your diameter, that is d is equal to 3 meter, and length, that is L, is equal to 7 meter. Okay, okay, now this is your axis. Okay, this is central axis, and what else is given? It is given that this is completely filled with water. Okay, okay, like totally it is filled with your water, there is no air. Okay, this one is completely filled with your water. Okay, now what is given here? So truck road with 7 meter long axis. So like it now, it is pulled by a truck. Okay, let's say this is moving in this direction here. Okay, and 7 meter long axis horizontal. Determine the pressure difference between the front and, let's say this is your location 1, and this is your location 2, between the front and the back end of the tank along a horizontal line. Let's talk about this line only. Okay, or this line only, from this point and this point. Front and back take a horizontal line. When the truck is accelerated, we have given the ax value, we have been provided in first both cases. Okay, accelerates and deaccelerates. Okay, now we know that your G is acting in downward direction always. Even if I don't mention your G, so we can like directly write it like this. Okay, so I can say here that my pressure is basically a function of, let's take your axis at this point. Okay, let's say this is your z axis and this is your x axis. Okay, so your pressure is function of x comma z. Okay, so your dp is equal to del p by del x times of dx plus del p by del z times of dz. Okay, now so I can write here your dp is equal to, now dp by dx can be written as rho minus rho ax times of dx minus rho az plus g times of dz. Okay, now if I like talk this between 2 points, or if I integrate it, so on integrating it, let's say from point 1 to 2, if I integrate this point 1 to 2, 1 to 2, so I will get p2 minus p1. p2 minus p1 is equal to minus rho ax is constant. Okay, dx is your x2 minus x1. Okay, minus rho times of az plus g times of z2 minus z1. Okay, now what we have to do, we have to calculate your pressure difference between, we have to calculate your p1 minus p2 between front and back end. We have to calculate p1 minus p2, and at a same like horizontal level. So at same horizontal level, z1 is equal to z2. We can say that z1 is equal to z2. So this will be your 0 at horizontal line, or same level, or at same level. Okay, okay, and if this term becomes 0, so I can write my p1 minus, or let me write it in next line here, your P1 minus P2 is equal to rho Ax times of x2 minus x1. Okay, now if I want to substitute value of Ax minus x2 minus x1, so this will be equal to L, so is equal to rho Ax times of L. Okay, now in first case it is given that Ax is equal to 3 meter per second square, so your P1 minus P2 will be P1 minus P2 is equal to rho times of, so since this is water, it is mentioned here that this is water. Okay, so this will become Ax times of L. L is your 7 meter, 7 into Ax, that is 5, sorry 3, so this is 21, so this become 21 kilopascal. Okay, so this is your Ax in first case, sorry pressure difference in first case. Now if I talk about B case, in B case your Ax will become, since it is deceleration, so this will be minus 4 meter per second square. Okay, so your P1 minus P2 will become rho times of Ax, that is minus 4, times of x2 minus x1, that is L, is equal to 7, so this will become minus 28 kilopascal. Okay, it means that here in case of deceleration, your pressure at P2 will be more than that of pressure at P1. Okay, I hope you get this point here. Now, so your acceleration, like in case of acceleration, your pressure at back is greater than that of pressure at front. Okay, and in case of deceleration, what we see, your pressure at back is less than that pressure of your front. Okay, let's move to the next question. So in this question, like it is similar to your last question also only. So here it is your milk. Okay, and level road 9 meter long. Okay, so this is your length. L is equal to 9 meter and D is equal to 3 meter. Okay, and the tanker is completely filled with milk, no air space, and it accelerates at, okay, accelerates at Ax is equal to 4 meter per second square. Okay, now if the minimum pressure in the tank is 100 kilopascal, determine the maximum pressure difference and the location of maximum pressure. Okay, so if your like truck is moving in, accelerating in this direction, so this should be your, like the tendency should be something like this of the floor for the free surface. Okay, but since it cannot be achieved, so we can say that pressure at this point will be your minimum, this point will be minimum, point will be minimum, and pressure at this point will be your maximum, that is, let's say this to be 0.2. I hope you get this point. Okay, like if it was, let's say, not there will be some air space. Okay, then like it would the free surface will try to form something like this. So this surface, like the water level will try to fall here, and at this side the level will try to rise. Okay, so we can say that pressure at point 1 should be your minimum and pressure at point 2 should be your maximum. Okay, so we have been given the value of like here mentioned, no, the minimum pressure in tanker is this, so we have been given the P1 is equal to 100 kilopascal. Okay, and determine the maximum pressure difference, that is delta P is equal to P2 minus P1. What should be this value, and location of the maximum pressure, maximum pressure. Now let's take the coordinate system here. Let's say that this is this axis is your z axis, this axis is your x axis, or we can also consider like in the last question, this is your z axis, this is your x axis, but this Ax should be not in this direction, Ax we consider is in this direction. is your Ax, and is equal to minus 4 meter per second square. Okay, so I can write my P is equal to P of x comma z, and from here I can write dP is equal to minus rho Ax times of minus rho Ax times of dx minus rho of Az plus g times of dz. Okay, now if I substitute the values here, so like if I integrate this, so I will get P2 minus P1 is equal to minus rho Ax times of x2 minus x1 minus rho Az is your 0, so rho g times of z2 minus z1. Okay, now if we substitute the values here, so minus let's take rho is equal to 1020 for milk is given. Okay, now Ax is your minus 4, x2 minus x1, so x2 minus x1 is your 9 meter L, minus here again your g, that is 9.81 into z2 minus z1. Now z2 minus z1 will be your minus 3. Okay, z1 minus z2 will be 3, z2 minus z2 will be minus 3. Okay, now so I have obtained P2 minus P1 is equal to, if we solve this, so this becomes minus 4 into 9, okay, plus 9.81 into 3, okay, into 1020. So this becomes P2 minus P1 becomes 6701.4 Pascal. Okay, this becomes your pressure difference delta P. Okay, now if minimum pressure is given, we have to calculate the maximum pressure. So maximum pressure, that is P2, will be your plus, minus. Now your P1 value is 100, okay, and 100 kilopascal, it's like this. So this becomes 106.7 kilopascal. Okay, okay, so we have obtained our pressure difference and your maximum pressure, that is P2. This is your, okay. Now let's move to the next question. So in this question, a rectangular tank is filled with heavy oil, okay, at the bottom and water at the top. As shown in the figure, the tank is now moved to the right horizontally with a constant acceleration, and 1/4 of water is spilled out. Okay, now use the geometrical consideration, determine how high the point A at the back of the tank on the oil water interface will rise under the acceleration. So let's say that the width or depth of this tank is 1 meter. Okay, so a volume of water, if I want to calculate volume of water, so I can write it as, like, since it is rectangular, so this will be your L into 1 is area into 1 is depth. Okay, this is L meter cube. Okay, now it is mentioned that V spilled is equal to 1/4 of volume of water, 1/4 of V water is equal to L by 4 meter cube. Okay, now when water is spilled, so your surface would become something like this. Okay, it should become something like this. So this is your volume that is spilled, this is your volume is spilled. Okay, so if I write volume is spilled is equal to, if I write it from here, so this will be like a triangular area of depth. This is like your triangular prism. Okay, something like this. So this volume will be your like half into base is your L, into height, that is 1 meter, into depth, that is 1 meter. So this is your L by 2 meter cube. Sorry, I am sorry, this height is your, let's say this is your depth, okay, up to this point. Okay, now this is your, this distance, let's say, is your let's say this is distance is your what should I say, let's say take it to be D. Okay, now, or let's say it to be H. Okay, now into H is equal to LH by 2 meter cube. Okay, now if I equate both of these, so from here I will obtain my H is equal to 1 by 2. Okay, and in meters. Okay, H is equal to half meter. So this will be the location, this will be something like this. Okay, now what is asked, using geometric consideration determine how high the point A at the back of the tank on the oil water interface will rise under this acceleration. Okay, so if this will become like this, so your oil water interface will also be something like this. Okay, so we have to find how much distance will it rise. Okay, let's say this distance to be y. Okay, or let's say that this point is A, so this point is your A dash. Okay, and let's say that this angle is alpha, and okay, so this angle is alpha, and let's say this angle is also your alpha. Okay, so I can say that tan alpha is equal to H upon your L, and this is also equal to your A dash divided by your this distance. Okay, that is your L by 2 divided by L by 2. Okay, because rise at this point will be equal to your should be equal to your fall at this level. Okay, and if I substitute the values here, so let's write H we know is 0.5 meter divided by L is remains same, is equal to 2 A dash times of L. So from here we have obtained A dash is equal to 0.25 meter. Okay, I hope you get this point. So now okay, so one more thing, you might be thinking that since this surface is free, this interface should originally the angle of inclination should be calculated using your tan alpha or tan, let's say this angle will be your, let's say that it should be like this, and this angle making is theta, where tan theta is equal to A upon G effective. Okay, but there is some difference. This will be applicable when this will form a free surface, but in this case question, what is happening in this question, this is not forming a free surface, this is an interface. Or if we consider to be like a free surface, so then pressure at each and every point should be same. Okay, and if we consider this like this, so what will happen, here height is less, here height is more, so pressure at these two points are not same. So these two lines, like this line and this line, must be your parallel lines. If this line and this line are parallel, only then will be pressure at this line at each and every point will be same. Okay, hence the slope for both will remain same. Okay, now let's move to your next question. So let's start this question. So in this question it is mentioned that a U2 shown in the figure is subjected to acceleration of A, okay, to the left if the difference between the free surface is, okay, so this is delta H is equal to your 0.2 meter. okay, and this h is equal to your 0.4 mm, 0.4 meter, sorry. Okay, we have to calculate your acceleration. So let's say that since this is same level, okay, so let's say that at this point, this is z and this is your x, okay, in the direction of a, okay. So we can say that our pressure is a function of x comma z, okay. So your dp is equal to plus del p by del z times dz, okay. Now what else I can write? I can write that my dp is equal to, now dp by dx is equal to minus rho ax times of dx, okay, minus dp by dz is equal to minus rho g. Now g effective is equal to g here, okay, so times of dz, okay. Now so let's say that this point here is your point 1 and this point here is point 2, okay, point is this point, okay. So let's integrate this equation from 1 to 2, from 1 to 2, from 1 to 2, okay, and both point 1 and 2 are in your liquid only, okay. So here I can write it as equal to your P2 minus P1 is equal to, this is your minus, now density in the oil will remain same, so density also, or liquid, or since it is liquid, so this is density of liquid times of g, sorry, times of ax. Now ax is equal to a, okay. Now this is your x2 minus x1 minus, so this term will become 0 because dz, like there is no change in the height, okay, so this term is 0. So from here we obtained p1 minus p2 is equal to rho liquid times of a times of l, okay. So if I calculate your p1 and p2, okay, so p1 is equal to rho of water times of g effective, that is g here, times of h plus delta h minus p2 is equal to rho of liquid times of g times of h is equal to rho liquid times a times of l, okay. Now if we solve this, so this is your g, that is 9.81 into h plus delta h is your 0.6, okay, minus rho of liquid time 1.6 times of g, that is 9.81 into h is your 0.4, okay. This term becomes this, and now divided by 1.6 and divided by L, that is your 0.5. So your A is equal to minus 0.49 meter per second square, okay. So to attain this given condition, where your this height is the water and this is your liquid with Hg 1.6, so with the width of 0.5 meter, okay, so your like this much accelerate in right direction with the acceleration of 0.49, but since it is given in left direction, so your acceleration is minus 0.49 meter per second square, okay. Now we will move to our next question. So in this question, so here is your vertical cylinder, okay. So your diameter is d and is equal to your 0.3 meters, okay, and your height of vertical cylinder, h is equal to 0.9 meter. This is your height. Now is partially filled with 60 centimeter high water. So this height is your 0.6 meter. H is equal to 0.6 meter. Okay, 0.6 meter. Okay. Now how much? Okay, now the cylinder is rotated at a constant angular speed. Okay, so this cylinder is being now rotated. Let's say it's rotated about this axis here. Rotated. Okay, is rotated at omega, or at n is equal to, or let's say omega, with the speed omega. Now determine how much the liquid level at the center of the liquid will drop as a result of this rotational motion. Okay, so what happens actually? What happens, like during rotation, your surface becomes something like this. Okay, now you have to calculate this value. Let's say this value is your y. So you have to calculate the value of y here. How much the liquid level at the center of the cylinder will drop as a result. Okay, now so this is your n. Okay, n is equal to 180 rpm. So your omega is equal to 2 pi n divided by 60. Okay, so your pi into n is your 180 divided by 30 is 18.85. 18.85 radian per second. This is your omega. Okay, let's say distance to be your L. Okay, and so we will write your pressure equation. So pressure for, in case of rotation, is a function of your r and z, or let me like mention them at a single point. Let's say from here we will mention r, and upward from here we will mention z. Okay, so your pressure is function of r comma z. Okay, so dp is equal to del p by del r times of dr plus del p by del z times of dz. Okay, now if I can write the value as dp is equal to rho r omega square dr plus, or minus rho g effective. So g effective will be g here times dz. Okay, so let's say that this is point, this point is your O, and this point is your 1. Okay, so let's integrate this from 0 to 1, 0 to 1, 0 to 1. Okay, now since point 1 and 0 are on the same line, so this will become p1 minus p naught. Okay, is equal to, now this dr, since it is with respect to radius, and since both are at same radius, so this will become 0, minus here it will become rho g times of z1 minus z1 node. Okay, now P1, I can write P1 is equal to pressure at this point, and let's assuming gauge pressure, so this point pressure should be, assuming it to be 0, minus P naught is equal to your rho g times of, and this point to be 2. Okay, let's say that this height from here up to your point 1 is also your capital H. Okay, so let's integrate this from point 1 to 2, 1 to 2. Okay, and 1 to 2, 1 2 2. Okay, so this will become P2 minus P1, and since both are your atmospheric pressure, so I can say that okay, let's write P2 minus P1. Okay, so P2 minus P1 is equal to rho. Now this is your omega square, and your integration of r omega square will be divided by 2 times of r2 square minus r1 square. Okay, minus, now here this will become rho g times of z2 minus z1. If we substitute the values here, so this will become 0, and because p1 is equal to p2. Okay, and here rho omega square by 2 times, let's say this is your capital, this radius is a capital R. Okay, so r2 is equal to capital R square, minus r1 square is equal to 0. Okay, minus, now here we can write rho g, this is your h. Okay, so from here I can write h is equal to r square omega square by 2g. So this is your height, this height. Okay, and now let's check if there is some over spillage of the liquid, or what is the like net height z2 minus z0 if I want to calculate. Okay, so let me start here. So I can say that volume initial is equal to volume final. Okay, now your initial volume is your initial volume. What is initial volume? That is pi r square times of h. This is your initial volume of a cylinder. Okay, now this will be equal to your, and this is your 0.15 meter. Okay, and v final is equal to your this total height, that is your pi r square times of z2 minus z1. This is your total volume up to this point. Okay, minus your volume of this paraboloid. Okay, and this is equal to pi r square h by 2. Okay, so if I want to, let's first calculate the value of h. So h is equal to r square, that is 0.15 square. Okay, times of omega square is equal to 18.85. Okay, divided by 2 divided by 9.81. Okay, and this h is equal to 0.407 meter. Okay, and if we substitute these values here, so this, so pi r square will cancel at all 3 points. Okay, and from here I can write that my z2 minus z1 is equal to h plus capital H by 2. So capital H divided by 2 is this value, and add your small h. Small h is 0.6. So from here I obtain z2 minus z1 is equal to 0.804 meter. Okay, and this distance is less than that of L, hence there is no spillage. Spillage. Okay, and since there is no spillage, so we can say that if I want to calculate y, so I can write y is equal to or I can write here your z2 minus z1, so or z0 is equal to z2 minus z0 is equal to capital H plus small h minus y. Okay, like in capital H, y is already included, but small h also y is included. So capital H plus small h minus y is equal to this value. So if I solve this here, so 0.804 is equal to capital H is your capital H is 0.407 0.407 plus 0.6 minus y. Okay, so this is minus 0.407 plus or minus 0.6. Okay, so your y is equal to 0.203 meter. So this is your drop in the liquid level at the center of the cylinder. Okay, I hope you get this point. And this is this is a node. Okay, total height from here to here. Okay, now move to next question. So in this question, let's discuss this. So in this question, it is mentioned that a 4-meter vertical cylindrical milk tank rotates constantly at 15 rpm. If the pressure at the center of the bottom surface is 130 kilopascal, determine the pressure at the edge of the bottom surface of the tank. Okay, density of milk is given. Okay, so system is something like this. Okay, so this was the initial level, let's say. Now we are rotating this at your omega is equal to or n. So we have been given n is equal to 15 rpm. So your omega is equal to 2 pi n by 60. Okay, and this is equal to your pi by 2 radian per second. Okay, now we have been given that p node is equal to node is at this point. Okay, this point is 0, and we have to calculate pressure at this point. Let's say this pressure to be 1. Okay, the p node is given as your 130 kilopascal. Okay, what else is given? Okay, so let me move it here. Okay, now we have to calculate the pressure. So for pressure calculation, we have to move to our most basic equation, that is dP is equal to rho r omega square dr minus rho g times of your dz. Okay, now if I talk from like integrate it from point 1 to 2, so this will become p2 minus p1 is equal to rho r square omega square by 2. Okay, minus rho g times of, now this becomes 0. Okay, dz is 0. So from here we have to calculate p2, sorry, not p2, this is your like p1 and p node. Okay, so you have to calculate p1. We know the value of p node is 130 in kilopascal. Okay, so let's write it as like this. Okay, is equal to rho is your 1030 times of r square here will be 2 meters, so 2 square times of omega square is pi square by 2 square, pi square by 2 square, pi by 2 is your omega. Okay, okay, now divide by 2, so this and this is cancel out. Now if I solve this, so I will obtain p1 is equal to, so this is your 1030 times of pi square. Okay, and divide by 2, so p1 becomes this plus 130123. Okay, so 135.0 0.08 kilopascal. This is a pressure at point 1, and that is your pressure at the edge of the bottom surface of the tank. Okay. Now let's move to next question. So here, a conical vessel of height 2 meter and base radius 2 meter. Okay, so we have a conical vessel. So let me draw it here. Okay, so it's something like this. Something like this. Okay. Now here is your conical vessel. So this should be your circular vessel. Oh, sorry, circular section. Okay. Okay, it's something like this. Now it is mentioned that this is your 90 degree. So your theta is equal to 90 degree. Okay, your base radius, that is this radius, your radius here, that is r, is equal to 2 meter, and your h is equal to 2 meter. Okay, what else given? Carries water whose volume is 1/2 of the volume of the cone. Okay, so let's say that this is your like level of water. This is your level of water. Okay, and let's say that the radius here is your small r, and this height is your small h. Okay, so we know that volume of water is equal to volume of half of volume of coin. Okay, half of volume of cone. Okay, so if I substitute the values here, so like volume of cone is 1/3 times of pi r square h is equal to half times of 1/3 times of pi r square h. Okay, so from here I can like cancel out these terms. Okay, so from here I can write my one thing. Okay, but like since this angle is your 90 degree, so this angle should be your 45 degree. This angle alpha is equal to 45 degree, so I can write that tan alpha is equal to r by h is equal to r by h. Okay, so from here I can say that this should be equal to 1 because tan 45 is 1, so I can say that r is equal to h. Okay, and this r is also equal to h, which is already given in the question. So from here I can say right that r cube is equal to h cube is equal to your 2 cube divided by 2. Okay, so your r is equal to h is equal to cube root of 4. Okay, I hope you get this point here. Okay, which is equal to your 1.59 meter. This is your like height and radius of water surface. Now the speed at which the vessel may be rotated to make the water just spill out. Okay, so let's say that this rotated at speed omega. Okay, so in that case what will happen? It should be like at the verge of falling, it should be something like this. Okay, let's say we can say here that for water like just to be spilled out, your volume initial will be equal to volume final. So volume of water initial is equal to volume of water final. Okay, so initial volume is we know this is 1/3 times of pi r square h and this should be equal to your volume of like after deformation, that is your 1 by 3 pi r square h. This is for total volume of the total cube cone. Okay, now minus the volume of paraboloid, that is your minus pi r square times of height of the parallelepiped divided by 2 times of height of parallelepiped, sorry, paraboloid, is equal to your, that is equal to your, we know that is equal to your r square omega square by 2g, or let's say here that is it z, let's say it to be z. Okay, and this dimension here is your z. This height is z, let's say. Okay, so if we solve this, so let's wait a minute. Okay, so this term, that is, so we can cancel out pi and pi. Okay, now rh square, that is 1.59 cube divide, sorry, 1.59 cube. Okay, divided by 3 minus 2 cube divided by 3, so this term, and multiplied by 2 divided by r square. Okay, and r square is equal to your 2 square, that is 4. So from here we have obtained our z is equal to 0.663 meter. Okay, and we can write your z is equal to, or height of the free surface in your rotational rigid motion is given by r square omega square by 2g. Okay, so from here we can calculate omega is equal to, so into 2 into 9.81 divided by r square, that is 4, divided by omega square, so this is your omega square. Okay, now if we take so omega square is equal to 3.254. Okay, so omega is equal to 3.254 square root, so square root. Okay, so is given by your omega is equal to 1.8 radian per second. Okay, I hope you get this point now. Now let's move to next question. So here, so let's so distance between the center of the two arms of the U2 atmosphere 30 centimeter. So this distance is 30 centimeter, and U2 contains 20 centimeter high alcohol in both arms. Okay, now the tube is rotated. The left arm is okay around this, where omega is equal to your 3.5 radian per second. Okay, now determine the elevation difference between the fluid surfaces in the two arms. Okay, so we can assume this to be, let's say, your container, where something like this. Okay, we have to calculate the liquid, if it will be liquid, so it will makes it something like this. Okay, and if we calculate this difference in height, or this height of your paraboloid, so that will be difference in the column height. Okay, so let me solve once using your classical or your analytical approach. That is, we can write dp is equal to rho r omega square dr minus rho g dz. Okay, now let's say that after your initial after rotation, your surface forms something like this. Let's say that here it reaches this level, and here it falls to this level. Okay, so it would be something like this. Liquid line will form something like this. Let's say this is a point 1 and this is a point 2. Okay, So we will integrate this equation from point 1 to 2. So this is P2 minus P1. Okay, and one more thing, like only from here also only we will take this as R and this is your Z. Okay, so your P2 minus P is equal to rho R square, or sorry, rho omega square by 2 times of R2 square R1 square, okay, minus rho G times of Z2 minus Z1. Okay, so we can say that P1 and P2 both are on surface, so both will be 0, is equal to rho omega square by 2 times of, now R2 square is equal to this distance, that is your 0.3 meter, minus R1 is equal to 0. Okay, minus rho G. Now this is the distance we have to calculate, Z2 minus Z1. Difference, determine the elevation difference between the two surfaces in the two arms. Okay, so let's say this to be, your, let's say this to be your y. Okay, times of y. Okay, so if we solve this, rho times of omega square is your 3.5 square 2 by 2 times of 0.3 square is equal to rho times of G times of y. Okay, we have to calculate y from here. Rho and rho will cancel out, so from here we can write y is equal to 3.5 into 0.3 square. Okay, divide by 2, divide by 9.81, so your y is equal to 0.0562 meter, and this is equal to your 5.62 centimeter, or 5.6 centimeter I can write simply. So this is your answer here. Okay, now let's move to next question. So in this question, the bottom quarter of the vertical cylinder tank of total height 0.4 meter. Okay, this total height is your, from here to here is your 0.4 meter. Now the diameter and the diameter 0.3 meter is filled with liquid Hg glycerine. Okay, here this is your Hg greater than 1 and this is your Hg is equal to 1. Okay, and rest with water as shown in the figure. The tank is now rotated about its vertical axis at a constant angular speed omega. Determine the value of angular speed when the point P on the axis of the liquid interface touches the bottom tank, and the amount of water that would be spilled out at this angular speed. Okay, so now it would be something like this. Your free surface would be something like this. Your water would be like this. Okay, wait a minute. Okay, and similarly your interface will be also be something like this. Okay, okay, so it's something like this. So it's something like this. Okay, so it's something like this. Sorry, not like, okay, I am sorry about that. Okay, it's something like this. Okay, it would be something like this, and these are two isobars. Okay, now we can say that let's say that this point is 1, this point is 2. Okay, and so what we can say here, let's say one more thing, let's say this point is 3 and this point is here 4. Okay, now, or let me mention it something like this. Okay, let's say that this point here is here 1, this point is here 2. Okay, and since it is like this, so what is happening, this side, or let me like use alphabets here, this is A, B. Okay, now here let's say this is your C, D. Okay, now so what I can say that during spillage what will happen, your volume of oil or glycerin, volume of glycerin initial is equal to volume of glycerin final. Okay, now initial volume is equal to your pi by 4 times of d square times of h. Okay, is equal to half times of, now this volume equal to this volume. Okay, now this is your half of this volume of the cylinder. Okay, is equal to pi by 4 d square times of AB. Okay, so if we solve this, so from here we will obtain AB is equal to 2h and h is equal to 0.1 meter, so AB is equal to 0.2 meter. Okay, okay, and we can say that since both of these isobars are parallel to each other, so we can say that this AB will be equal to your CD also. Okay, now first we have to determine the value of angular speed. So for that, so I can write that this height of that is CD is equal to r square omega square by 2g. Okay, so your CD value is your 0.2 is equal to r square, r is equal to 0.15, 0.15 square times of omega square. We don't know the value of omega. Okay, omega square divided by 2 times of 9.81. Okay, so this is your 0.4 into 9.81. Okay, divided by 0.15 square. Okay, now if we take the square root of this, so this is your omega is equal to 13.2 radian per second. Okay, okay, so this is your angular speed of your tank. Okay, now second is the amount of water that would be spilled out of the at this angular speed. So B is your volume spilled is equal to initial volume of water, that is your pi by 4 times of d square times of 3h. Okay, minus the volume of paraboloid, that is half times of pi by 4 d square. Okay, times your CD. Okay, is equal to pi by 4 times of d square, that is 0.3. Okay, times of 3 times of h, that is your 0.3. Okay, minus 0.5 into CD, that is your 0.2 meter. Okay, now this is equal to your pi divided by 4 into d square, that is 0.09. Okay, into now 0.3 minus 0.1, that is a 0.2. So your volume of water spilled is your 0.0144 meter cube. Okay, so these are two parts which were asked here. So I hope you get the solution. Okay, now let's move to your next question. uh, 1.2 meter diameter and 3 meter high sealed vertical cylinder. So this cylinder is sealed vertical cylinder. Is completely filled with gasoline, whose density is this. The tank is now rotated about vertical axis at the rate of 70 rpm. Okay. Determine the difference between the pressure at the center of the bottom and top surface. Center of the bottom and top surface. Okay. So like this. Let's say that if this is your base, let's say the center of bottom is your point one number one. This is your point number two. So here part is we have to calculate the difference in the center of bottom and two, that is P1 minus P2. Second is difference between the pressure at the center and edge at the bottom surface. So between P1 and P3. Okay. Now if I want to calculate your pressure, so for pressure, as I mentioned earlier, we directly write your standard equation, that is dP is equal to rho r omega square dr minus rho g dz. Okay. And here 1 minute. So this is your r and this is your z. Okay. So in A part, we have to calculate your difference between pressure at center of bottom and top surface. So P1 minus P2. So we'll integrate it from P1 and P2. So this will become P2 minus P1 is equal to rho omega square by 2 times of R2 square minus R1 square minus rho g times of Z2 minus Z1. So your P2 minus P1. Okay, but we have to calculate the at center bottom and top. So P1 minus P2 we have to calculate. So P1 minus P2 is equal to rho omega square by 2 times of now R2 minus R1 square. So R2 and R1 are both at center. So both are 0. Okay. Minus rho g times of, so Z2 minus Z1 is your 3 meter. Okay. So your P1 minus P2 is equal to, sorry, is equal to rho g times of 3, that is so this is your 29.43 kilopascal. Okay, so this is your first part. Okay, now if we talk about B part, so it is mentioned the difference between the pressure at center and edge at the bottom. So we have to calculate P1 minus P3. So P1 minus P3, if I write it, so I will write rho m square by 2 times of R1 square minus R3 square minus rho g times of Z1 minus Z3. Okay. So if you substitute the values, so rho omega square by 2 times of, now R1 is 0 minus R3 is your 0.6. Okay, 0.6 square minus rho g times of, now Z1 minus Z3 will be your 0. Okay, so your P1 minus P3 is equal to rho omega square by 2 times of your minus 0.36. Okay, now we know that our omega is rate of rotation is your 70 rpm and density is this. Okay, so we have density is equal to 740 kg per meter cube and n is equal to 70 rpm. Okay, and omega is equal to 2 pi n by 60. Okay, so omega is equal to pi into n, that is 70 divided by 30. Okay, so this is your 7.33 radian per second. Okay. Okay, so if we substitute these values here, so this is omega square, okay, into density, that is 740 divided by 2, okay, into 0.36. So we have obtained our T1 minus P3 is equal to minus 7.16 kilopascal. Okay, so this is solution. Here we have solved both parts. So from here what we can say that pressure at the bottom is greater than that of pressure at top. Okay, and what we can say that pressure at center is less than that of pressure at edge. Okay, okay, because only then will it be negative, because it is negative, so your P at center is less than that of P at edge. Okay, now we can talk about either it is a top or bottom. Okay, now let's move to next question. So here this will also be your last question for this session. Now the rate of rotational speed of three tube system is a figure is omega is equal to 10 radian per second, is determine the water height in each tube leg at the rotational speed. Will the middle tube be completely empty? Okay, so there are two parts. First part is determine the water height in each tube leg. Second is at what rotational speed will the middle tube be completely empty. Okay, so what will happen here if I talk about like this? So this will be something like this. Sorry. Something like this will happen here, like it will fall from here to here. Okay, and from here it will rise and something like this. Okay, something like this will be, although like the figure is not very smooth, but it should be somewhere around here only. Okay, like this. Now this is your point here, like your this will be your level here. After rotation this will be level, and here the level will be here. Okay, let's say this is your leg 1, leg 2 and leg 3. Okay, these three are legs, and we have to calculate your height in each tube leg. Let's say this is your origin. Okay, and here we are measuring radius, and from here we are measuring your z. Okay, so now we can write dp is equal to rho r omega square dr minus rho g dz. Okay, now if let's one more thing. Let's say this is 0.1. Okay, and let me make some corrections here. Let's say this pipe is A, this leg is B, this leg is C. Okay, so this point is 1, this point here is 2, and this point is 3. Okay, now if I talk about your free surface, so I can write at free surface your dp is equal to 0. Okay, so I can write your rho r, or like if I substitute this equal to 0, so I can write your omega square r dr is equal to your rho g dz. Okay, now if I integrate this, so what will I obtain? I will obtain omega square r square by 2 is equal to, sorry, not rho, only g. Okay, so z in t time of z plus, or I can write it as like, let's send these two this side. Okay, by 2g is equal to z plus c1. Okay, so it means that at any location at any location, I can say that my location of your free surface can be given by z is equal to omega square r square by 2g minus c1. Okay, so this is your height at any location. Okay, now I can say that at r is equal to 0, we can say z is equal to z2. Okay, so z is equal to z2, so I can say that c1 is equal to minus z2. Okay, so we can say that our z2 or I can write that my height of the liquid in B is equal to z2. Okay, now and your length of liquid in A is equal to length of liquid in C is equal to. So from this equation, what else I can write? That ZA I can write here it as omega square. Now this is your RA square, or R1 square. I can write R1 square by ZA1, write it Z1 by 2G minus Z2. Okay, or plus Z2. Okay, because minus will become positive. So your HA is equal to Z1 and is equal to Z2 plus omega square R1 square by 2G, and here similarly we can write ZT is equal to Z3 is equal to Z2 plus omega square R3 square by 2G. Okay, now again I can say that this total column length will be your HA, that is HA plus HB, or I can say here from mass conservation or volume conservation. From volume conservation, what would be this? So HA plus HB plus HC is equal to 3 times of H. Okay, because here the fluid will remain always. Okay, so from here what I can write, I can write HA plus HB plus HC is equal to, this is your 3 times of Z2 plus your omega square by 2G times of R1 square plus R3 square. Okay, is equal to 3 times of H, that is your H is your 15 centimeter, that is 0.15. Okay, so if you substitute the values here, so let me substitute the values here. So 3 into this is 0.45 minus 3 times of minus W square by 2G. W square is your 100 divided by 2, that is 50, divided by 9.81 into now R1 square plus R3 square. So R1 is equal to 0.2 square plus 0.1 square. Okay, so this becomes this. Okay, divide, now if we divide it by 3, so we have gotten our Z2 is equal to 0.065 meter is equal to, so this becomes your Z2 is equal to 6.5 centimeter. Okay, now so we can write my HA is equal to HB is equal to HC is equal to. Okay, so HA is equal to, so I can directly write from here that my HB is equal to 6.5 centimeter. Okay, so initial height was 15 centimeter, now final height will be at HB is 6.5 centimeter. If I talk about your HA, so HA is equal to, now additional term is omega square, that is 100 divided by 2, that is 50, divided by 9.81, okay, into R1 square. Now your R1 square is your 0.2 square, okay, so this becomes your 20.4 centimeter. Now if I talk about your HC, so this is your divided by 4 is equal to, sorry, this become 26.9 centimeter, okay, and this become 11.6 centimeter, okay. This is HA plus HB plus HC. Now, so these are our height in each of three tubes, height of liquid column in each of three tubes, first, okay. Second is, what is rotational, at what rotational speed will your middle tube be completely empty, okay. So it means that second point is saying for middle tube to be completely empty. What should be the case? Your Z2 is equal to 0, okay, and this, where if this happens, okay, so from this equation we can write that your omega square by 2g times of R1 square plus R3 square is equal to 3 times of 0.15, okay. Now if we solve this, so we will be obtaining 0.45 times of g, that is 9.81 divided by 50, okay, okay. Now sorry, we have to calculate omega dash from, let's say this is omega dash, okay, this is Z2 dash is equal to 0, so here omega dash, okay, we have to calculate. So this is 0.45 into 2 into 9.81, okay, and divided by your R1 square plus R3 square. Your R1 square is equal to 0.04 and this is 0.01, so 0.05 total, okay, is equal to this. And if we take a square root, so we will obtain your omega dash is equal to 13.29 radian per second, okay. So the given rotational speed was your 10 radians per second, okay, and in case of 10 radian your Z2 was equal to 6.5 centimeter. Now if I want my Z2 to become 0, your rotational speed must be your 13.29, that is 3.29 radian per second more than the initial, okay. So with this we have completed our this question, and this is your last question for this session, so thank you.